Hey guys, welcome to our vlog, and in today's episode we're diving into the fascinating world of programming language concepts. Specifically, we'll be exploring the general problems of describing syntax, the formal methods of describing syntax, dynamic syntax, and lexical and syntax analysis.
The general problems of describing syntax. But before that, what is syntax? Syntax is the way that words are put together to form sentences in a language. It's like a set of rules that helps us create sentences that make sense and are grammatically correct. It's important to know what is syntax because it allows us to communicate effectively with others and to understand the meaning of what others are trying to say or writing. So there are 5 general problems of syntax. First is complexity. Languages are complex because they have many rules and exceptions that govern the arrangement of words and phrases to convey meanings. The second general problem with syntax is variation. Syntax is the way that words are put together to form sentences in a language. It's like a set of rules that helps us create sentences that make sense and are grammatically correct. The third general problem of syntax is ambiguity. Ambiguity in a language happens when a sentence or words can have more than one meaning or interpretations. This can happen when the rules of syntax are unclear or allow for multiple interpretations, which can cause confusions or misunderstanding. And lastly is the difficulty in identifying the rules. Sometimes it can be difficult to identify and define the rules of syntax because they are often implicit or unconscious in language use. This means people may have not been aware of the specific rules that they are following when they speak or write.
Formal methods of describing syntax. Formal language generation mechanisms, usually called grammars, are commonly used to describe the syntax of programming languages. Now here are some of the most commonly used formal methods. Context-free grammars. CFG is developed by Noam Chomsky in the mid-1950s. It is just a set of rules or productions that express the ways the tokens in the language can be grouped, ordered, and classified. For example, a very simple production on the right specifies the part-of-speech class of words from an example vocabulary. You can see here that these rules say, I'm gonna consider anything that is in this list of words, cat, fish, chicken, to be a noun. And I'm gonna consider ate, yawned, and crossed to be verbs, and so on. The symbol that corresponds to words in the language are called terminal symbols, and the set of rules that introduce the terminal symbols is referred to as the lexicon. Backus-Naur form, or BNF. It was invented by John Backus to describe the syntax of Algol 58. Now, BNF is a simple way to write down the rules of how code should be structured in a programming language. It uses symbols and rules to show which combinations of code elements are allowed. It's like a set of building blocks and instructions on how to put them together to create a program. A fairly simple example where I'm just trying to interpret a number, see if it's a valid number. So I might have digits and then it's 0, 1, or 2, or 3, or 4 to 9. Then I might represent an integer as being a digit because it could be just one digit, or a digit followed by an integer. Grammars in general tends to be inherently recursive. This is true to our natural language grammars, as well as our programming language grammars.
Dynamic semantics is a subfield of formal semantics that analyzes the meaning of natural language expression by taking into account of dynamic and contextual factors that influence their interpretations. In dynamic semantics, the meaning of an expression is not just determined by its intrinsic properties, but also by the discourse context in which it is used, including the speaker's intentions, the beliefs, the assumption of the interlocutors, and the effects of the expression of the ongoing conversation.
The word bunk is a classic example that demonstrates the importance of context in understanding the meaning within language. It is because the meaning of the word can vary depending on the context in which it is used. Now here are a few examples. In the context of finance, bank refers to a financial institution where people can deposit and withdraw money and conduct various financial transactions. For example, I need to visit the bank to deposit my paycheck. Now in the context of a river, bank refers to the land alongside a body of water. Example, the picnic spot is by the riverbank. Now these examples demonstrates how the word bank can have different meanings depending on the specific context in which it is used. Dynamic semantics allows us to interpret the intended meaning by considering the context and other relevant factors. Lexical analysis and syntax analysis. These are the first two phases in the process of parsing and analyzing programming languages. They are both essential steps in understanding the structure and meaning of a program. Lexical analysis. It is the process of breaking down the source code of a program into a sequence of meaningful tokens. A token represents a logical unit of the programming language, such as keywords, identifiers, operators, literals, or punctuation symbols. The lexical analyzer scans the source code character by character, grouping them into tokens based on predefined patterns or regular expressions. For example, let's consider the following C code. The lexical analysis phase would then break this code into tokens like the tokens generated during lexical analysis are then passed on to the next phase, which is syntax analysis. Syntax analysis. It is the process of analyzing the structure of a program based on the sequence of tokens generated by the lexical analysis phase. Okay, so for example, using the tokens from the previous example, the syntax analysis phase would build a parse tree like this. Syntax analysis determines whether the program is syntactically correct, according to the language grammar. If the program contains syntax errors, the parser may report these errors, providing information about the location and nature of the errors.
Now we talk about name binding. Name binding is the process of assigning a name to an object. It is important because it allows us to refer to the object using the name instead of having to ask its address or same other identifier.
The scope refers to the visibility of an object within a program. In static scope, an object is visible only in the block in which it is declared and any blocks nested within it. In dynamic scope, an object is visible in the block in which it is declared and any blocks that have been executed before the current block.
Extent refers to the lifetime of an object. In static extent, an object is allocated where the program is compiled and remains in memory until the program is terminated. In stack extent, an object is allocated on the stack and is removed from memory when the scope in which it was declared is exited. In heap extent, an object is allocated in the heap and remains in memory until it is explicitly deallocated.
Constant variables are variables that cannot be changed after they are declared. They are usually used to assign values that are not likely to change, such as the value of vide or the speed of light. They are declared with the keyword const in the most programming language. Types are used to classify data in programming language. They are used to specify the type of variable being declared and the operation that can be performed on them. There are common types, which is integers, float, string, and booleans.
Subroutines. Subroutines are usable blocks of code that are used to perform specific tasks. They are often used to simplify complex code and make it easier to maintain. Subroutines can be declared with the keyword sub. In most programming languages. Modules. Modules are collections of related functions, types, and constants that can be imported into a program. They are used to group related code together, making it easier to maintain and reuse. Modules are declared with the keyword module in most programming languages.
Shallow binding and deep binding are two techniques used in programming language for resolving references to variables or functions. Shallow binding refers to a technique where a reference to a variable or function is resolved based on the current scope at the time the reference is made. In other words, the binding is determined by the current scope of the caller rather than the scope where the variable or function was defined. This can lead to unexpected behavior when a variable or function is called from a different scope than the one in which it was defined.
Deep binding, on the other hand, refers to a technique where a reference to a variable or function is resolved based on the scope where the variable or function was defined. In other words, the binding is determined by the scope where the variable or function was defined, rather than the current scope of the caller.
To illustrate the difference between shallow binding and deep binding, consider the following example. In this Python code, outer underscore function is an enclosing function that defines a variable x with a value of 10. It also defines an inner function named inner underscore function that prints the value of x. In the deep binding example, we create a new variable x with a value of 20 within the deep binding example function scope. We then call outer underscore function, which returns inner underscore function. When we invoke the inner method, it prints the value of x from the outer function scope, which is 10. This demonstrates deep binding because the value of x is determined by the environment where the inner function was defined. In the shallow binding example, we define x with a value of 20 within the shallow binding example function scope. The inner underscore function is defined within the same scope and prints the value of x from its immediate environment. When we invoke inner underscore function method, it prints the value of x from the shallow binding example function scope, which is 20. Now this illustrates shallow binding because the value of x is determined by the environment where the inner function is called. Note that deep binding and shallow binding are not common in most modern programming languages, as they are usually based on static scoping or lexical scoping, where the scope of a variable is determined by its position in the source code rather than the runtime environment.
A closure is a programming concept that refers to the ability of a function to access and manipulate variables from its parent or outer scope, even after the parent scope has finished executing. In other words, a closure or close over the variables in its outer scope, making them available for use within the function. Closures are useful for a variety of programming tasks such as maintaining state in a function or creating private variables that cannot be accessed from outside the function. They can also be used to create functions that generate other functions such as a functional programming.
Here is an example of a closure. In this example, the makeCounter function returns an inner function that increments a count variable each time it is called and logs the new value to the console. The count variable is defined in the outer scope of the inner function, so it is closed over and can be accessed and modified each time the inner function is called. When the makeCounter function is called twice to create two separate counters, counter 1 and counter 2, each counter has its own separate count that is closed over by its own inner function. This allows each counter to maintain its own independent count state. Aliasing, overloading, and polymorphism are all concepts in programming that relate to how functions and variables can be used and manipulated. Aliasing refers to the situation where two or more variables or functions have the same name or reference. This can occur intentionally, such as when creating an alias or nickname for a variable, or unintentionally, such as when two different functions happen to have the same name. Aliasing can lead to confusion and errors in code if not managed carefully.
In this example, the add function is first defined to add two numbers together. However, the function is then redefined to add three numbers together, creating an alias for the original add function. When the add function is called with 2 arguments, it uses the original definition to add the numbers together. When called with 3 arguments, it uses the new definition to add all 3 numbers together.
Overloading refers to the ability of a function or operator to behave differently depending on the types or numbers of arguments passed to it. In other words, 2 or more functions with the same name can exist, each with different arguments list. This allows a programmer to write functions with the same name that can operate on different data types or handle different numbers of arguments. Overloading is commonly used in object-oriented programming languages like Java and C++. Polymorphism refers to the ability of an object or function to take on many forms or to have multiple behaviors depending on the context in which it is used. Polymorphism can be achieved in different ways, such as through inheritance, where a subclass can inherit and override methods from a superclass, or through interfaces, where different classes can implement the same interface in different ways. Polymorphism is a key concept in object-oriented programming and can make code more modular and extensible.
The example also includes 2 classes, rectangle and circle, that extend a base class shape. Each subclass overrides the getArea method to calculate the area of the shape in a different way. The shape arrays contains instances of both subclass, demonstrating how polymorphism allows a function to behave differently depending on the object it is called on. When the getArea method is called on each shape object, it calculates the area of the shape in a different way, depending on whether the shape is a rectangle or a circle.